You believe it? That goon Hasskreidt wasn't going to do any work this weekend. Said if I wanted it done, I had to do it myself. Nice. What a clown. Okay, so we're looking at the homework that's on page 12. It starts off with Hayoshi walks 10 meters in 3 seconds. What is her walking rate? This is just like finding the unit rate. And we were doing that last month with ratios and proportions. We've got 10 meters. And it says, can you see that? And that is walked in 3 seconds. Okay, if we put that on our calculators, (10) divided by 3 is going to equal 3.33 meters repeated. Okay? Problem 2. At this rate, how long does it take her to walk 100 meters? Okay, well that's easy. We've got the rate. So now all we have to do is figure out how long it would take at that rate for her to walk 100 meters. So we would have 100 meters divided by 3.3 meters per second. Okay, the meters cancel each other out. What's 100 divided by 3.333? 100 divided by 3.333 is about 30 seconds. The answer is going to be about 30 seconds. They asked us how many, they said she was going to walk 100 meters, and we have this rate. So we're dividing that 100 meters into 3.3 meters per second increments. So how many of those are there? There's 30. See, I get through this stuff faster than Hasskreidt. He's kind of a clown. Don't you think? Unlike me. Okay. Everybody should be able to see that. Next question. Suppose she walks at the same rate for 50 seconds. How far does she walk? Okay. So now they're giving us the time, and we have to figure out how far she walks. So that's 50 seconds times 3.3 continuous meters per second. Okay, this time the seconds cancel. I'm sorry. Hold on. Yeah, how far does she walk? So this time the seconds will cancel each other out. And she's going 50 seconds at 3.3 meters per second. 50 times 3.333. And that's going to equal 166.6, if I round up, 1.7 meters. There's a decimal there. Okay? Bueno. Now, the hard part, and this is the most important thing that we're learning, is how to take a mathematical problem in verbal form and put it into mathematical form. 1D says write an equation that represents the distance d that Hayoshi walks in t seconds. Okay? The distance, which we define as d, in t seconds. Well, we have the rate, and by the way, if you remember from last week, what is a slope? One of the definitions of a slope is a rate. Okay? All right. So an equation that represents the distance d that's walked in t seconds. So d is going to equal what? Well, we know our speed is 3.33 meters per second, right? Don't pay attention to that loud cat. Quiet, you. Quiet, you. Quiet, you. You too. 3.33 seconds times what? I'm sorry, 3.33 meters per second times t seconds. That should make sense to you. This is the speed at which she's going, and she's doing that for t seconds. So our equation is going to be d equals 3.33 times t. T standing for the amount of the seconds that she's walking. All right? Number 2, Milo walks 40 meters in 15 seconds, and Miro walks 30 meters in 10 seconds. Whose walking rate is faster? So again, this is similar to what we did in the past, and that's the reason why we did ratios and proportions for so long last month. Okay? Okay, so Milo walks 40 meters in 15 seconds, and Mira walks 30 meters in 10 seconds. So whichever of these two numbers is higher, that is, whichever of these two quotients, that is this divided by this is 40 meters, and this is 15 seconds, and this is 30 meters, and this is 10 seconds. Whichever of these two ratios is higher is going to be the person whose walking rate is going to be faster. Okay. 40 divided by 15 is 2.667. I know that might be difficult to see. Here, it's equal to this. Let's put the answer down here. 2.67. Okay. $30 divided by 10, I don't even need to do that on a calculator. 30 divided by 10 is going to be the same as 3 over 1, which is going to be 3 meters per second, and this was 2.67 meters per second. So the person who is going the fastest is going to be Mira. Okay, the last one. I'll do part of the last one. That last one you have to do on, the last two you'll have to do on your own. It says, the table gives the distance that Jose, Mario, and Melanie travel for 3 hours. Assume that each person cycles at a constant rate, which is, by the way, a really huge assumption because we all know in the real world that's not the way it is. Find the average rate at which a person travels during the first 3 hours. Excuse me. So we have, let's do Jose. Okay, Jose travels a total of 30 miles divided by 3 hours. So the average rate in miles per hour is 30 divided by 3 equals 10 miles per hour. Okay, or a more mathematical way of putting that would be like this. 10 miles per hour, because that's the ratio that we're going, the ratio of miles to hours. Okay? Next question. Find the distance each person travels in 7 hours. Well, now we have the rate, don't we? So that you can probably even do in your head. He's going 10 miles per hour for 7 hours. Each hour he travels 10 miles. Okay, 10 times 7 will equal 70 miles. You'll notice up here, once again, the hours cancel each other out. You have one in the numerator and one in the denominator, which leaves us with miles, which is what we wanted our answer to be in. That's a way of checking yourself. Okay, make sure that your units are going to be in the units that you want, otherwise you might be making a mistake. Graph the time and distance data for all three riders on the same coordinate axis. Okay, I'll do that for Jose. You have to do the rest of them. Since this is at a constant rate, the distance that they travel is going to be increasing 10 miles for each hour, right? So it's increasing at a constant rate. This is the hallmark of a linear relationship. An increase or a decrease at a constant rate. That's what gives us that nice linear shape. Okay? On the y-axis, we have the distance. On the x, and this is going to be difficult to see because I've got a small board here. On the x-axis, we have the hours. In other words, the distance that is traveled depends on the number of hours traveled. Okay, not the other way around. The number of hours traveled is not going to change because of the distance. Okay? Let's set this up by tens. The reason why I'm doing that is because if you look, at some point in this exercise, they ask you to see how long it takes a person to travel 70 miles. So we need to have a y-axis that goes up to 70 miles. 20, 30, 40, 50, 60, and 70. And our hours are going to be at least up to, are you able to see this? Kind of. Remember, the x-axis is the hours. This might go below what the camera can see. Oh no, you can see good. 1, 2, 3, 4, 5, 6, 7. Okay? All right, let's graph this data for Jose. At time 0, he had gone 0. At 1 hour, he went 5. By 2 hours, he had gone 10 miles. And by 3 hours, he had gone 15. Okay? Find the distance. Oh, I already did that. Use the graph to find the distance each person travels in 6.5 hours. Now, this might not look absolutely perfect because, again, I'm not working with I'm having to draw this freehand. But what we're going to do is just continue this graph. Unfortunately, I don't have a yardstick or something nice and big to continue it with, so I'm just going to have to kind of approximate it. Okay, that didn't quite work because it really should be up a little bit higher like this. And you would be able to see that after 6 hours, they had gone 65 miles. Okay? If you draw this on graph paper, it will look right, and you will be able to use the graph as a way of finding the distance. You would just go to the 6.5 hour spot in hours, and just go up to where it touches the line, and that should give you the distance that was traveled in 6.5 hours. Okay? And in that same way, you can use the graph to figure out how long it takes a person to travel 70 miles by simply going to the 70 mark and going over to the right until you touch the graph, and that will be the number of hours it took to go 70 miles. Okay? All right. I'm late for watching the Bears. Got to see them hopefully stop. Was it Baltimore they're playing? Anyway, whoever they're playing. Have a good Sunday. By the way, I'm going to be absent tomorrow because my daughter's sick. She has what I had last week. So I will have lessons for you, and I'll probably post a video for the 8th graders as well. Bye-bye.